Okay, so let's have this example. An unknown resistor is connected between the terminals of a 3-volt battery. Energy is dissipated in the resistor at a rate of 0.54 watts. The same resistor is then connected between the terminals of a 1.5-volt battery. At what rate is energy now dissipated? Okay, so let's have the first condition. So we're given a resistor, and then it is connected to a battery. Okay, so this is the first condition of 3 volts. And then the energy, yung energy dissipated, so that's a power. So the power is equal to 0.54 watts. Ayan. So what information can we get here? Okay, so remember the law of conservation of energy, di ba? Kung ano yung na-receive na, ideally, kung ano yung na-receive na power nung ating resistor is the same uh, amount of energy na ibinigay ng ating source. Ayan. So, kung given tayo ng power tsaka yung voltage kung saan nakakonect yung resistor natin, so that means these two are in parallel. So therefore, yung voltage din natin sa resistor is also 3 volts. So if you will get a relationship between power and the voltage, pwede nating makuha yung resistance. Di ba yung power is equal to V squared over R. Ayan. So therefore, R is equal to V squared over P. So that's equal to 3 volts squared over 0.54 watts. So the resistance is equal to actually it's 50 over 3 or approximately 16.67 ohms. 6.67 ohms. Wait, teka lang. 3 squared. 3 squared divided by 0.54. Tama. Oh, yeah. Okay, so we have found the resistance. Next, the same resistor is now connected to a battery na ngayon ang voltage niya ay 1.5. Ang tinatanong ay rate of energy now dissipated. Ngayon, ano ngayon yung power dun sa ating resistor? Siyempre, it's the same resistor. So that means it will have the same resistance na 50 over 3. Kung gusto natin kunin ng power, so that's this is the same, V squared over R. So that's equal to a 1.5 squared divided by 50 over 3. So what is the power? Okay, so the answer is 0.135 watts. Okay, so the power dissipated is 0.135 watts. Okay, so let's take another example. Okay, a common flashlight bulb is rated at 0.3 amperes and 2.9 volts. So these values of the current voltage are under operating conditions. So pag sinindi mo siya, pag sinindihan mo siya, yan yung current na dadaan sa kanya at saka yung voltage across sa light bulb, flashlight natin. Okay, if the resistance of the bulb filament at room temperature na 20 degrees Celsius is 1.1 ohm, okay, so what is the temperature of the filament when the bulb is on? So consider that the filament is made of tungsten. So I've written the alpha or the temperature coefficient of tungsten, which is at 4.5 times 10 raised to negative 3. Okay, so yung first condition natin, so, okay, when at 20 degrees, so remember, this value is also at 20 degrees Celsius. The resistance initial, so let's call that the initial resistance, is equal to 1.1 ohm. Ayan. Okay. So at 20 degrees. So natanong is, ano yung final temperature kung ang resistance nating final will be that of the operating value, which is, kukunin natin siya sa Ohm's law, that is V over I. So that's equal to 2.9 volts over 0.3 amperes. So the resistance is 9.6, tama ba ako? 9.67. 9.67 ohms. 2.9 divided by 0.3. 9.67 ohms. Now, if you will get the ang formula natin in finding the temperature, di ba? Ang R final is equal to R initial times 1 plus alpha times T final minus T initial. Ayan. Okay? So, we're looking for T final. So, ang gagawin natin is R final is equal to R initial plus, i-distribute ko yan, alpha R initial times T final minus T initial. And then, so R final minus R initial is equal to alpha R initial times T final minus T initial. Then divide natin to ng alpha R initial. So T final minus T initial is R final minus R initial over alpha R initial. Or T final then is R final minus R initial over alpha R initial plus T initial. So T final is equal to 9.67 minus 1.1 all over 4.5 times 10 raised to negative 3 times 1.1 plus 20. So what's our T final? Negative 3 plus 20. It's 1,750.64 degrees Celsius. Ayan. Okay. Ang pinakamadali actually is pwede nyo siyang i-shift solve. So, dito pa lang, pwede na natin kunin yung sagot. So, that's 9.67 alpha equal, or that's 2.9 over 0.3 alpha equal 1.1 times 1 plus 4.5 exponent negative 3 times alpha x minus 20. Okay, shift solve. Hindi kaya ng hindi siya pwede sa complex. Ayun. So that's 2.9 over 0.3 alpha equals 1.1 times 1 plus 4.5 exponent negative 3 times alpha x minus 20, shift solve. 150.64 degrees Celsius. Okay, so that is the final answer. Okay, so let's have another one. So a heating element is made by maintaining a potential difference of 75 volts across the length of a nichrome wire that has 2.6 by 2.6 times 10 to the negative 6 meters squared cross section. I think that's the area. Okay, so the given voltage is 75 volts, and then the area, cross-sectional area of the wire is 2.6 times 10 raised to negative 6 meters squared. Again, nichrome resistivity. So the resistivity of nichrome is given. So that's 5 times 10 raised to negative 7 ohm meter. Ayan. So for letter A, if the element dissipates a power of 5,000 watts, what is the length of the conductor? Okay, so what's the length of the conductor? Okay, so that means we need the resistance to find because diba, resistance is equal to rho L over A. So we're given the resistivity and the area. We need to find the length, so we need the resistance. Now, we are given the voltage and the power, so we can find for the resistance. So what's the relation of power with voltage and resistance? That's P is equal to V squared over R. Okay, so that means R is equal to V squared over P. And that is 75 squared over 5,000. So what is the resistance? It's 1.125 ohms. Okay, and then, okay, since we now have the resistance, so pwede na natin kunin yung length. The resistance is rho L over A. So L is equal to resistance times area over the resistivity. So that's 1.125 times 2.6 times 10 raised to negative 6 all over 5 times 10 raised to negative 7. So the length is 5.85 meters. Yan, tama ba ako? Ulitin ko. 1.125 times 2.6 times 10 raised to negative 6 divided by 5 times 10 raised to negative 7. And 5.85 meters. Okay, for letter B, may difference. What if daw yung voltage ay 100 volts? It's used to obtain the same power. So same yung power, but the voltage is different. So what should be the length? So same lang naman din. So we need to find the resistance. So resistance is still voltage squared over power. So that's equal to 100 squared over 5,000. So the resistance is equal to it's 2 ohms. 2 ohms. Okay, so therefore, I'll just copy the formula na directly. So L is equal to 2 times 2.6 times 10 raised to negative 6 all over 5 times 10 raised to negative 7. Okay, so the resistance is 10.4, the length, sorry, the length is 10.4 meters. 10.4 meters.